Okay, this is Taylor series example 1. All right, in my opinion, the first and best example to get your mind wrapped around these things is our old friend, the geometric series. Okay, now remember, this thing equals 1 over 1 minus r when r is between -1 and 1, non-inclusive. So not including -1, not including 1. And it diverges, think of as goes to infinity, otherwise. Otherwise meaning when r is not in between -1 and 1. Okay, so now a power series we can think of as an infinite polynomial. So I'm going to write this as f of x like so. Okay, now let's leave that there. Okay, so now remember domain, right? What is the domain of a function? Think of the domain as all the numbers that go in that make sense. All right, so now let's pick an x between -1 and 1. Let's say f of x equals a half, or f of a half. This is 1 plus a half squared plus a half cubed plus a half to the 4th, going on and on and on, adding like that forever. Now, because 1/2 is between -1 and 1, we know that this converges to 1 over 1 minus a half. 1 over 1 minus a half, let's see, that's 1 over a half, which is equal to 2. Okay, so 1/2 is in the domain of this infinite polynomial, this infinitely long polynomial, f of x equals 1 plus x squared plus x cubed plus x to the 4th plus x to the 5th plus x to the 6th plus x to the 7th, and on and on and on and on. Right, and so, but what happens when we plug in, say, f of 2? 2 isn't in our domain. Now you see what's happening here? 1/2 squared, that's 1 to the 4th. Or 1 over 4, sorry, not 1 to the 4th, but 1/4. Here we have 1/8. There we have 1/16, and so on. Doing this addition forever and ever and ever, we eventually get to 2. But doing this addition over and over and over again, we just get bigger and bigger and bigger. Right here we have 4, 8, 16, next 32, so we're just getting bigger, 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 bigger. Goes to infinity. Okay, so the domain of our function, f of x equals 1 plus x squared plus x cubed plus x to the 4th, and so on, our domain for this function, this infinitely long polynomial, is the interval from -1 to 1. This is what we call the interval of convergence. It's the interval of numbers that you can put into this thing and actually get a number out. This is the interval of convergence. Okay, now I just want to draw one more connection here. This number right here this is my constant Taylor polynomial right here. This right here, this is my linear Taylor polynomial. This is my quadratic Taylor polynomial. This is my cubic. This is my fourth degree Taylor polynomial. So constant 1 plus x is my linear. 1 plus x squared is my quadratic Taylor polynomial. 1 plus x squared plus x cubed is my cubic Taylor polynomial. 1 plus x to the fourth plus x cubed plus x to the fourth is my fourth degree Taylor polynomial for the function f of x. All right, and so the idea is that the Taylor polynomials in this case, they converge. Each of these polynomials, they converge to this function f of x. They converge when we're in the interval of convergence. Otherwise, this thing has no meaning to us whatsoever, right? It only has meaning within the interval of convergence. And that's the first example.